Hello students, this is Dr. Diaz and today we're going to talk about metric system and also we're going to talk a little bit about density. So the English system was used primarily in the British Empire. The French organized a committee to devise a universal measurement system. After about 10 years, the committee designed and agreed on the metric system. So the metric system offers simplicity with a single base unit for each measurement. So in length, we use meter. So that we use the symbol m, mass, gram, volume, liter, and time, second. Pay attention in the symbols here. And I'm pretty sure the people or the students that came from Europe or South America, they're gonna use those units. But I'm pretty sure, and here, even knowing that America, we use the English system, we're gonna learn today how to convert the units, because this is very important in chemistry, engineering, and every area, because we need to talk in the same language in all the world. This is why you have the metric system basic unit. So meter was defined as 1 divided by 10 millions of the distance from the North Pole to the equator. A kilogram or 1,000 gram was equal to the mass of a cube of water measuring 0.1 meter on each side. A liter was set equal to the volume of 1 kilogram of water at 40 Celsius degree. Here we have the prefixes, metric prefixes, that help us to enlarge or reduce numbers. The same thing, remember when I said we're going to use the scientific notation for very large numbers or very small numbers, because that we have a better format and it's easy to talk. So when instead to say 1,000 grams, we're going to say 1 kilogram. And here we have some prefix that I need you to get used with. So if I use kilo, I know that is 10 power to the third. So 1,000 gram would be 1 kilogram. So we have giga, mega, tera. So you see the exponents over here. You don't need to memorize those. Okay, if you need to convert some units, I'm gonna tell you. You don't need to memorize all, but I think it's very important to memorize just at least kilo, deci, centi, milli, and micro, because this we use a lot in chemistry and biochemistry as well. Okay. The names of metric units are abbreviated using symbols. Use the prefix symbol followed by the symbol for the base unit. So kilo, K, and they have a meter, M. Milligram, so we have milli, so we have here, and we have a gram. So microliter, so we have the micro over here, and the liter. Nanosecond, so we have the N for nano, and then S for second. Okay. So an advantage of the metric system or international system of units is that it's a decimal system. It uses prefixes, as I said before, to enlarge or reduce the basic unit. For example, kilometer is 1,000 meter. 1 millimeter is 1 divided by 1,000 of meter. But it's much easier to say millimeter than 1 divided by 1,000 of meter. Do you agree? So a unit equation relates two quantities that are equal. For example, 1 kilometer is equal to 1,000 meters. And we can use the symbols. Also, you can write 1 centimeter is equal 1 divided by 100 of meter. Or we can say 100 centimeter is equal 1 meter. And this is very important because we're going to use the unit conversion factor, also known as unit factor, which is a ratio of two equivalent quantities. for the unit quantity, 1 meter is equal 100 centimeter. We can write two unit factors over here. 1 meter divided by 100 centimeter or 100 centimeter by 1 meter. If I want to convert like 2 centimeter, I'm gonna use a meter, I'm gonna use this because I want to be able to cut off the centimeter because I want it just in meter. So then it will be 2 divided by 100 meters or 0.02 meters, right? So if I want to convert 2 meters, of course in centimeter, I'm gonna use this because my priority is centimeter, so it must be up there. So I'm gonna cut this, and I'm gonna have 200 centimeters. Okay, so the unit factor that you're gonna use depends what unit you need at the end, what the unit you have to convert to. So an effective method for solving problems in science is the unit analysis method. This is very important. And if you learn and if you're confident now, I'm really sure that you're going to do great in stoichiometry, because most of the problems in stoichiometry is when the students are not able to convert units. Okay? This is also often called dimensional analysis or the factor label method. Actually, this is the most common term, dimensional analysis. Okay? So how are we going to do this? We're going to apply the unit analysis methods. So you write down the unit asked for in the answer, and then you write down the given value, and you multiply by the unit factor. Then you're going to have your units that you need in your answer. Here is an example. What is the mass in grams of a 325 milligrams aspirin tablet? So what you have is milligrams, and we want grams. So we're going to write down the given value. So 325 milligrams, and now I have the unit factor. 1 gram divided by 1000 milligrams. So we're going to cut off milligrams, and we have grams. So we're going to divide this by this. Okay, remember this is a fraction, right? So another example, a hospital has 125 deciliter, see, deciliter. I know this is 1 liter is equal to 10 deciliters of blood plasma. What is the volume in milliliters? So what you need is milliliter, and we have deciliter. So we need to first convert deciliter and then to liter, because this is the conversion factor that I have. So we're going to do is the given value, I have 125 deciliter, then I'm going to convert deciliter and liter. See that liter is up here, this is our priority. So if I want to cut off any unit, you must divide it by the same unit, so you can cut off. And then I want cut off liter because what I want is milliliter, so I use the unit factor. The milliliter must be up here, so we can cut off liter. Okay, so we multiply this by this and divide the result by 10. So we have 12,500 milliliters. Good? So another example is the mass of Earth is given in kilogram, and they're asking nanogram, and I have the unit factors over here. So look, I could say 1 kilograms per 1,000 grams or 1,000 grams per kilogram. So if you want to convert to grams, so grams must be up here, not here. So you're going to use this, right? So what you're going to do is using 10 grams, 1,000 grams divided by 1 kilogram, so you can cut off. So now I'm going to have my results in gram. And I want to convert grams to nanograms. Again, the priority must be up here because I want to cut off the units, gram. So to cut off, grams must be divided by grams. So I multiply this by this by this and divide by 1. So this is wrong over here because look at this. when you have a product and they have exponential, why is it raising? Look at this, 1022 times 10 cubic. Oh my god, why is it raising here? 10,9. So we're gonna add this. So 22 plus 3 plus 9. So that will be 34, right? So it's not this because 22 plus 3 plus 9. So we have 14. So then we're gonna have 3 over here, is 34. So it's 1 nanograms. Okay. So the English system is still very common in the United States. We often must convert between English and metric system, so we prevent errors like this. We see the cartoon, the designer is looking like, oh my god, what I did it, right? Because the customer says, like, you still don't understand the metric system, do you? Because probably gave them the unit is like a meter, and now he decided to use English unit, so now it's bigger than he expected. So we're gonna use the metric English conversion, and it is pretty much the same that we did before. So, but when applying this metric equivalence, assume 3 significant digits over here, because the metric and the English systems have different reference standards. There are no exact equivalents. However, the United States Bureau of Weights and Measure has redefined 1 inch as exactly equal 2.454 centimeters. So I have 1 pound like 454 grams, 1 quarter like 946 milliliters, and 1 second like 1 second. So 3 significant digits for all. Okay, so let's keep doing conversions. So the length of American football field, including the end zones, is 120 yards. What is the length in meter? So given that 1 yard is 0.914 meters. So I encourage you to pause your video and start doing by yourself. So the given that's in yard, so I could say 1 yard is not has 0.19 meters, or 0.914 meters divided by 1 yard. So of course, if you want a meter, this must be up here, so I'm gonna not use this, I'm gonna use this. Okay, so I have 110 meters. Okay, it's all pretty much the same. So here another example. Half gallon carton contains 64.0 ounces of milk. How many milliliters of milk? So we are in milliliters, and we have here all the information: 1 quarter, 2 ounces, and 1/4 2 milliliters. So if I have ounce, so I'm gonna use 1/4 to 32 ounces because I want to cut off this, right? And then if I have a quarter and I want a milliliter, so quarter must be down here because I want milliliters up here because this is the unit I want. Okay, so they're giving that and this, and then we can get our answer. So we multiply 64 by 1 by 946 and divide by 32. Okay. So a marathon is another example, 26.2 miles. What is the distance in kilometer? So the problem gives us that 1 kilometer is 0.62 miles. So what we're gonna do, they ask to round to 3 significant figures, so we're gonna do this. So to round to 3 significant figures, we should use 42.0 kilometers. So then you go with this, okay? Just remember, the unit you want is your priority, it must be up there. And if you want to eliminate a unit, you must divide by the same unit. Okay? Some measurements have a ratio of units. For example, the speed. Speed limit on many highways is 55 miles per hour. How would you convert this to meters per second? So first you convert miles per meters and then hours per second. Or you can do all together, like in this example. So we have 105 kilometers per hour and 1 meters per second. So I have all the conversion units over here. So if you want a kilometer, want a meter, so we're gonna use 1,000 meter divided by 1 kilometer. So then I can cut off kilometer. And then I have hour down here, but I want a second. So second must be down there and hour must be over here. So I can cut off hour and I will keep second. So it will be 29.2 meters per second. Okay? So just to talk a little bit about the importance of this, let's remember what happened before. So the World Trade Center footprint was 150 square, not 150 square feet. NASA engineers mixed metric and English units when designing the Mars climate orbiters. The engineer used kilometers harder than miles. So the spacecraft approached too close to the Martian surface and burned up in the atmosphere. See how important it is to know how to convert units? Another very important thing in chemistry is the percent concept. A percent expresses the amount of a single quantity compared to an entire sample. A percent is a ratio of parts per 100 parts. The formula for calculating percent is shown like here. So we have a part divided by the total multiplied by 100. I think better is to work with an example. Like this example here. The first thing when you read the exam, bronze is an alloy of copper and tin. If a sample of bronze contains 79.2 grams of copper and 10.8 grams of tin, what is the percent of copper? So I need the total mass and I need the parts. Okay? So the total mass will be the sum of copper and tin. So, and the part is the copper over here. This is what they're asking me for. If you want to know the thing, will be 10.8 grams divided by the total. And then we're going to have the percentage. Okay? So this is pretty easy, and most of the things that you buy, it's in percentage. If it tells you 2% of sugar, so you're going to get the total mass, and you're going to find the quantity of sugar over there in grams, right? So a percent can be expressed as part per 100 parts. So 25 can be expressed as 25 divided by 100, and 10% can be expressed 10 divided by 100. So we can use a percent expressed as a ratio, as a unit factor. For example, rock is 4.70% iron, so 4.7 grams in iron and 100 grams of sample. The Earth and Moon have a similar composition. Each contains 4.7 iron. What is the mass of iron in a lunar sample that weighs 92 grams? So first we want grams of iron. We write down the given, which is 92 grams of sample, and then we apply the unit factors. So 4.7 grams iron and 100 grams of sample. And then we run for three significant figures, and we have this. Simple. Okay? So now I know the quantity in grams of iron in that quantity of sample. So the volume of an object is really easy to calculate because you're going to multiply the length times width and times thickness. So all three measurements must be in the same unit. You cannot mix the units. My advice, always use the unit. If you multiply centimeter by centimeter by centimeter, you're going to have a cubic centimeter. But if you have meter, you cannot multiply that. So it's going to be this. Okay? You cannot mix it units. Okay? So if you have meter over here and all centimeter, so you convert meter to centimeter, or you convert all the centimeter to meter. Okay? So the liter is the basic unit of volume in the metric system. 1 liter is defined as the volume occupied by cube, that is 10 centimeters on each side. So a liter is equal to 1,000 cubic centimeter. And I know that 1,000 cubic centimeters equal 1 liter, and 1 liter is equal 1,000 milliliters. So 1 cubic centimeter is equal 1 milliliter. Let's see this example, and I will ask you to read and try by yourself. Okay? So the problem says the car engine displays a volume of 498 cubic centimeter in each cylinder. What is the displacement of a cylinder in cubic inch? Oh, we want cubic inch, and we have 498 cubic centimeter. And the problem gives us that 1 inch is equal to 2.54 centimeter. So we're going to use this 3 times. Make our life easier. Okay? So I know centimeter must be down here. If I divide just 1 time, it would be square centimeters, and then I divide 1 more time, it would be centimeters, then divide 1 more time, it would be nothing. So centimeter divided by centimeter is 1, so it would be inch, right? So cubic inch. Easy. So if a solid has an irregular shape, its volume cannot be determined by measuring the dimensions. You can determine its volume indirectly. So how are we going to do that? By displacement. So if you put our object inside of the cylinder over here, volumetric flask, so we partially fill the volumetric flask over here 50 milliliters. Then we drop the solid that we want to know the volume. See that the volume increased over here. So what you're going to do is subtract this by this, and you have the final volume. So which is the volume of the solid. Easy. Also, we can measure the volume of gas if this gas is not soluble in the water. So first, we have all this balloon full of water. As soon as the reaction happens, it will produce gas, and the gas will pull the water to the other container, which is a beaker. So all this volume over here was displaced by the gas produced by this reaction. So I know the volume of gas produced. Another very important concept that you need to learn is the density. So the density of an object is a measure of its concentration of mass. And density is defined by mass as the mass of an object divided by the volume of the same object. Mass divided by volume. You can see over here that we have 3 beakers with water, and we have 3 different spheres. One is quark, and I know that I can predict the density of the quark. At least I know that it's lower than density of water because it's floating. Wood must be pretty close to the water because it's half floating and half sink. So it's in the middle over there. It's not sink, it's not floating completely. So the density must be pretty close to each other. But metal is heavier, so I know the density is greater than the water. So we have different factors that will influence the density, like type of materials, like I saw before, the temperature. If you increase the temperature, we cause the density to decrease. Just remember the balloon. If you warm the air inside, the balloon gonna goes up because the density of the air inside is lower than density outside. So this is why it goes up. Physical states. So we will alter the arrangement of molecules. Remember this, the ice. So when you have ice water and you have liquid water, so it's solid and liquid, the ice floats in the water. That means the density got lower, right? So pressure also influences a lot, more in gas and the very minimal factor in liquids and solids. If you keep the temperature constant and you increase the pressure, we can increase the density. So the pressure and density are directly proportional for gas at constant temperature. So normally the density is expressed in different units. We can use grams per milliliters or grams per cubic centimeters. And normally for gas and liquids, you're going to use grams per milliliters. And for solid, you're going to use grams per cubic centimeters. Just pay attention on the units when you are working. So here we have some examples for the density for common substances, like ice, and we have liquids like water. So see, the ice is 0.917 grams per cubic centimeter, while the water is 1 grams per cubic centimeters. And gas, if you look to the air, is 1.29 grams per milliliters. Compared to the hydrogen, we can see 0.09 grams per milliliter is lower than the air, right? Hydrogen is lower density than the helium. Ammonia has higher density than the helium. So the density value of each gas in this table over here is given at 0 Celsius degree at pressure equal normal atmospheric. Remember that I said that I could estimate the density when I gave you the example of beakers with 3 different materials, balls over there. We have a wood, cork, and metal. So this is an example of this. We have 2 different liquids over here. I have water and another liquid over here that is denser than the water. So if I put an object over here and another liquid over here that is lighter than this liquid, but it's heavier, greater density than this liquid, but it's lower than the water. So if I know the density of this and this, I will predict it very close the density of this object over here. And this happens with the same thing over here. I know that it's denser than water, so it will be bigger than 1 gram, right, per milliliters. But if I go to this liquid, I know that it's lighter than this. So if I know the density of this and density of water, I can predict easily the density of this. So let's calculate first. What is the density of platinum nugget that has a mass of 224.50 grams and a volume of 10 cubic centimeters? Recall the density is mass divided by volume. So the only thing you need to do here is divide mass by volume. Okay? But if we can use the density as a unit factor, then probably going to find a question of this in your exam. So here I have a car battery that contains 1,275 milliliters of acid. If the density of battery acid is 1.84 grams per milliliter, how many grams of acid are in this car battery? So I know the volume. So we have this volume given. And I know the density. So see, I use grams per milliliter because what I need is grams. So it's up over here, your priority. And I can cut off milliliter over here. Remember, if you divide the unit by the same unit, we have 1, so you're going to stay with the units with 1. So let's practice a little bit more. Here is what is the density common antifreeze in units of grams per milliliters. So they are giving you the mass and the volume, but also the unit conversion. Are you able to do it? You can do it directly, or you can do separate, like first convert mass and then convert volume, and then you calculate the density. Or you can do everything the same. So just pause your video and try by yourself. Here, so first, what I did was convert mass in grams using the unit factor given by the problem. Then I convert the volume. So I have quarter to liter because they gave me this. And then I convert liter to milliliter. So I have the volume in milliliter and I have the mass in grams. So now I will divide grams by milliliters and I have my final volume. What I said before is that you can do separate or together. So here it's all together. So just remember, if you want to cut off, you need to divide. Like a quarter you divide by quarter. So we have grams, and then here we have per milliliter. So I cut off liter with liter, and they have milliliters over here. So it's the same thing. Just choose the way that you feel more comfortable. Temperature, as I said, is a very important factor. It's a measure of the average kinetic energy of individual particle in motion. So it's all about movement, right? So if you increase the temperature, you increase the motion, so the particles will be like crazy, far away from each other. Imagine if it's a gas. They just remember the balloon. This is why balloon goes up. It's the lower density, and the particles start hitting the wall of the balloon more constantly. So there are 3 temperature scales: Fahrenheit, Celsius, and Kelvin. And Kelvin is the absolute temperature scale. We don't have negative values for Kelvin. So this is why we call absolute zero. Okay. So standard and absolute temperatures is Celsius. If you have absolute zero over here, Kelvin, so we have a negative 459.67 Fahrenheit or 273.15 Celsius degree. So the relationship between Fahrenheit and Celsius temperature scale is linear. Therefore, this relationship can be represented in the standard format of an equation for a straight line. I will not ask you to record the formulas, okay? If you need that, I will give it to you during the exam. And then you can go to Fahrenheit to Celsius or Celsius to Fahrenheit, okay? To just solving the previous equation for Celsius degree, and they have Celsius to Fahrenheit. And to convert Celsius to Kelvin is pretty easy, because you only need to add 273 or 273.15. It depends what I say to you and a problem. Okay, if I give you 273.15, you're gonna use that. So the body temperature is normal 98.6 Fahrenheit. What is the body temperature in Celsius degree? So you're gonna use the formula that I gave it to you and just substitute the values, and you're gonna have 37 Celsius degree. Then you're gonna convert to Kelvin, just add 273, and you're gonna have 310 kelvins. If you use 0.15, so you're gonna have this. Okay. Heat concept. Heat is the measure of total energy, and temperature measure the average energy of particles in the system. Heat is often expressed in terms of joules or calories. It depends what you talk about. When you look to the food, you're gonna talk about calories, right? Just don't get confused with heat and temperature. They have different concepts over here, like we saw before. So look to those 2 beakers over there. One has 500 milliliters of water, 100 degrees Celsius, and the second one, 1000 milliliters of water at the same temperature. Can you say that the beaker on the right has twice the amount of heat? Or the beaker on the left has twice the amount of heat? Or both beakers has the same amount of heat? Try it. Tell me, A, B, or C? You got right if you told A. Because although both beaker below have the same temperature, the beaker on the right has twice the amount of heat because it has twice the amount of water. Just imagine if I get a very huge potato and put it in the first beaker, 500 milliliters of water, and the same huge potato, the same size, in the second beaker. So I have more heat in the second because I have more water. So we accommodate better my whole potato over there, right? So the heat transfer there will be better. So we have twice the amount of water, we have twice the heat. Okay? The specific heat of a substance is the amount of heat required to raise the temperature of 1 gram of substance and 1 degree Celsius. It's expressed with the units of calories per gram. Is like this. Calories per gram Celsius degree. The larger the specific heat, the more heat is required to raise the temperature of the substance. So, in this unit, we talked about the basic units in the metric system, which is grams for mass, liters for volume, and meters for distance. The base units are modified using prefixes to reduce or enlarge the base units by factors of 10. I asked you to get used with kilo, milli, centi, deci, those units that you commonly use it, like in chemistry and biochemistry. And we can convert between metric and English units using unit factors. This is very important. Unit equation is a statement of two equivalent quantities, like 1 liter is 1000 milliliters. A unit factor is a ratio of two equivalent quantities. If I say that 1 liter is 1000 milliliter, or I could say 1000 milliliter for 1 liter. So the unit factor will be used in accord with what you want at the end. So unit factors can be used to convert measurements between different units. And the percent is the ratio of parts per 100 parts. Remember how to calculate the percent. And volume, we can measure and calculate the volume, multiply length times width and time thickness. You can also determine it by displacement of water. Density is mass divided by volume. Temperature is a measure of the average energy of the particle in a sample, while heat is a measure of the total energy of a substance. So if you have the same quantity, the same temperature in two different beakers, but we have more liquid in this one of the beakers, that beaker with more quantity, we have more heat, but the temperature are the same. Specific heat is a measure of how much heat is required to raise the temperature of 1 gram of substance. So that's it. That's all for now. Bye.